So today we are going to talk about the projectile motion. Now what is projectile motion? Projectile motion is motion of any object that we throw in space. Okay, so it follows a path something like this, a parabolic path. Alright, now let's suppose we throw this object in space. So it follows trajectory just something like this. Okay, it follows a parabolic path. Now first of all, we'll study the equation of the path of this projectile. Okay, so suppose this is y-axis, this is x-axis, and the location from where we throw this projectile in air, it is suppose the origin. So now this projectile or this object, it has some initial velocity. So suppose u bar is its initial velocity. So suppose this is u bar. Now we can resolve this velocity into two components. Okay, so this u bar can be resolved into two perpendicular components, one along x-axis and another one along y-axis. So suppose the initial angle between the path of projectile and the ground, suppose that initial angle is theta. Okay, so u bar makes an angle theta with the ground. Then we can resolve this u bar along two components, ux and uy. So u bar is equal to ux times I cap plus uy times j cap. And what is ux and uy? So we learned in last lecture that ux will be equal to u cos theta and uy will be equal to u multiplied by sin theta. Okay, so and u will be equal to what? So u will be equal to square root of ux squared plus uy squared. Alright, then this is the initial velocity. What about the acceleration? Is there some acceleration acting on this projectile? So of course yes, there is acceleration due to gravity and it acts vertically downwards. Okay, there is no acceleration along x-axis, the acceleration is there only along y-axis. So the acceleration acting on this projectile is acceleration due to gravity. Okay, its magnitude is g, and since it is acting in downwards direction, we will say a is equal to minus of g. Okay, and if I want to denote it by a vector, then since it is acting in y direction, I will say a bar equals to minus g. G is the magnitude of acceleration, it is 9.8 meters per second squared. So a bar is minus g multiplied by unit vector along y-axis, and the unit vector is j cap. Okay, so this is the initial setup. Now let's find an equation for the path of this projectile. So let's recall the second kinematic equation of motion. It says s equals to ut plus half at squared. Alright, so we can write this for the motion in x direction as well as in y direction, because acceleration is not changing. So sx equals to ux times t plus half of ax times t squared. And how much is ax? Since ax is 0, we can write sx, which is x at some time t minus x position at start equals to just ux times t. Okay, since there is no acceleration along x-axis. After that, we can say sy equals to uy times t plus half of ay times t squared. Now let's substitute the values of uy and ay in this equation. So we get y at some time t minus y at start equals to what? Uy times t, and ay is minus g, so minus half of g multiplied by t squared. Okay. After that, let's substitute the initial position and initial velocity. So we know x naught equals to 0, y naught is also 0, since our particle or our projectile, it is starting from the origin. So, and ux equals to u cos theta and ui equals to u sin theta. Okay, so if we substitute all of this, these two equations, this equation and this equation, they give us x equals to ux times t, that is u cos theta multiplied by t. Okay, so suppose this is equation number 1, and y equals to ui times t minus half of g times t squared, and ui equals to u sin theta. So we have y equals to u sin theta into t minus half of g t squared. This is suppose equation number 2. Okay, now from this equation 1 we can find out t equals to, so from equation number 1, I can say t equals to what? If I take this u cos theta on the other side, it goes into the denominator. So I get t equals to x divided by u cos theta. Okay. So from equation 1, we get t equals to x divided by u cos theta. And now if we substitute this into equation number 2, so our equation number 2 is y equals to u sin theta into t minus half of gt squared. So substituting in equation 2, what do we get? We get y equals to u sin theta times t, and t is x divided by u cos theta minus half of g multiplied by t squared, and t is x divided by u cos theta and square of that. Okay, so here we see that this u and u gets cancelled out. Okay, and sin theta divided by cosine theta gives us tan of theta. So we can write this as y equals to tan of theta multiplied by x minus half of, I will write this as g divided by u cos theta squared is u squared cos square theta and multiplied by x squared. Okay, so now in this equation, suppose tan of theta is some alpha, some constant, because initial angle of the projectile with the horizontal direction, it is theta. Okay, and that initial angle will be fixed. Okay, so if we know the initial angle, then tan of theta will be a constant. Alright, so this is some constant alpha, and g is constant, the initial velocity is constant, okay, and theta is constant. That's why this is also a constant. So I can say that tan of theta is some constant alpha and this is some constant beta, and I can write this equation as y equals to alpha times x plus beta times x squared. So this is now the relation between x and y, okay, and if we look at this equation, this is an equation of a parabola, okay. So that means the path of projectile is parabola. Now next, let's derive an equation for the maximum height of this projectile, okay. So our projectile, it starts at this position and it reaches up to this maximum height. So now let's see what happens to its velocity at the maximum height. So we know that the instantaneous velocity, it is tangential, okay, it's tangential to the path. So at this point the velocity is tangential to this path. At this point it will be in this direction, so it can be still resolved along x and y component. Now when the projectile reaches to the topmost position, so when the projectile reaches over here, if we draw tangent to its path, then it points in this direction. So it means that at the topmost position, the projectile only has velocity in horizontal direction or x direction, and there is no velocity along y direction, okay. So at topmost position, the velocity of projectile, it will point in horizontal direction only, okay. And we can also understand it in this way. So as this projectile goes up, what happens is the acceleration is downwards, and that's why its velocity in y direction, it goes on decreasing, and as it reaches to the topmost position, the velocity in y direction will become 0, okay. Now from this we can find out the time taken by projectile to reach that topmost position, and it is known as time of ascent, okay. So till the time the projectile goes up, it is known as the time of ascent. So if we write first kinematic equation of motion, so it is Vy equals to Uy plus Ay into t, and if we substitute Vy and Ay into this equation, so Vy is 0, Ui we know it is u sine theta, and Ay is minus g, okay. So suppose the time taken by projectile to reach that topmost position, we call it time of ascent. So at topmost point Vy is 0 and t equals to, let's suppose, t suffix a, okay. So ta is time of ascent. So if we substitute in place of t, let's substitute t suffix a over here, then we can write this equation as, if we take this minus g times ta on the other side, it becomes plus, so it is g multiplied by ta equals to u sine theta, and therefore t suffix a will be equal to what? U sine theta divided by g. Okay, so we got an equation for the time of ascent. Time taken by projectile to reach the topmost position is equal to u sine theta divided by g. Then let's substitute this Ta equals to u sine theta over g into second kinematic equation. So second kinematic equation is Sy equals to uy times t plus half of ay times t squared. Okay, so now at topmost point y will be equal to what? Y will be equal to this much. Okay, so it is equal to the maximum height h max of the projectile. So at topmost point y is equal to maximum height of projectile. So now this Sy can be written as, the displacement in y direction can be written as y at some time t minus y at 0. Okay, so this is y minus y naught equals to uy times t, and ui is u sine theta. Okay, so u sine theta times t plus half of ay times t squared, and ay is minus g, so we have half of g times t squared minus half of g times t squared. So if we substitute t equals to Ta, then y becomes what? It becomes h max. So we get h max minus y naught is 0. So h max equals to u sine theta times Ta minus half of g times Ta squared. Now let's substitute this equation for Ta, the time of ascent. So we get u sine theta times Ta is u sine theta times g divided by g minus half of g multiplied by Ta squared, which is u sine theta over g squared. We have h max equals to u sine theta multiplied by u sine theta is u sine theta squared over g minus half of g multiplied by u sine theta squared divided by g squared. So this g and the square gets cancelled out, and we are left with, I will say, u sine theta square divided by g minus half of u sine theta square divided by g. So it is half of u sine theta squared divided by g. Okay, or we can write this as h max is equal to u square, sine theta square is sine square theta divided by 2g. Okay, next thing is to find out how much distance it goes on the ground. Okay, so if the projectile is projected from a horizontal surface, then suppose it starts from here, from the origin, and it falls on the ground at this position. So how much is the distance covered by projectile on the ground. Okay, that we want to find out, and that distance is known as the horizontal range. Okay, so we denote it by r. So for this point we can say x is equal to r, and we want to find out an equation for this horizontal range now. So now again, what will be the y coordinate of this projectile at this position? So at start y is equal to 0, and for this position also y is equal to 0. So if we substitute this y equals to 0 into the second kinematic equation of motion, which is relation between the position and time, then we get time taken by projectile to go at this position, or time for which the projectile was in air. It is also known as time of flight. Okay, so t is time for which the projectile is in air. It is known as time of flight. Okay, so for t equals to capital T, y will become 0. Okay, so we have y minus y naught equals to uy times t minus half of gt squared. So let's substitute t equals to capital T. So on left hand side we have 0 equals to uy times t minus half of g multiplied by t squared. Now I will take this minus half of gt squared on the other side. So I get half of gt squared equals to uy times t. Okay, so this t gets cancelled out with the squared. So now I will take this 2 and g on the other side. T equals to uy upon g and multiplied by 2. Okay, 2 goes into the numerator and g goes into the denominator. So 2 uy divided by g. And how much is uy? So uy is y component of initial velocity, and it is u sine theta. So we get t equals to 2 times u sine theta divided by g. And if we recall, the time of ascent was equal to what? It was u sine theta divided by g. Okay, and total time of flight for this projectile is 2 times u sine theta divided by g. So that means the time of descent, the time for which projectile moves downwards, okay, it is equal to what? This time of flight minus time of ascent. So we get time of descent of this projectile. So t suffix d equals to t minus ta, and that is equal to 2u sine theta divided by g minus u sine theta divided by g is u sine theta divided by g. So this is time of descent. Okay, so this means that if the projectile is projected on a level surface, that means a horizontal surface, then the time for which it goes up is equal to time for which it goes down. Okay, so the time of ascent is equal to time of descent, and sum of time of ascent and time of descent is time of flight. All right, so now if we substitute this time of flight into this equation, So we had x equals to what? Ux times t only, because there is no acceleration in x direction. So when t is equal to the time of flight, the x position will be equal to what? It will be the horizontal range of the projectile. Okay, so we get r equals to ux times capital T. And what is ux? So ux is u cos theta, and we found that t is equal to 2 times u sin theta over g. So if we multiply this out, we get u squared multiplied by 2 times of sin theta into cosine theta divided by g. And we know that sine of 2 theta is equal to 2 times sin theta into cosine theta. So sine 2 theta equals to 2 times of sine theta into cosine theta. Then we can write r equals to u squared multiplied by sine of 2 theta divided by g. Okay, so this is the equation for the horizontal range of the projectile. Now next, let's find out the angle at which the projectile should be projected so as to get the maximum height and maximum horizontal range. So for maximum height, okay, the height attained by projectile, we had equation for that. It is u square sine square theta divided by 2 times g. So in this equation, u is constant, the initial velocity of the projectile is a constant, g is constant. So the only variable thing in this equation is the angle. Okay, so what is the maximum value of sine theta or cosine theta of an angle? So maximum value for sine theta is equal to 1. Okay, so therefore the angle corresponding to this maximum height is, suppose, theta max. Okay, so theta max is, suppose, the angle corresponding to the maximum height. Then if sine of theta max is equal to 1, then what will be theta? So we know when theta is 90 degrees, sine of theta is equal to 1. So theta max should be equal to 90 degrees. So we get h max equals to u squared divided by 2g, and the angle at which this projectile should be projected with respect to ground, it is 90 degrees. That means the projectile should be projected straight upwards. Okay, all right, so it shouldn't have any velocity component in x direction. All the velocity should be in y direction. So this is the angle corresponding to the maximum height. Now what will be the angle corresponding to the maximum horizontal range? Now theta max is, okay, I am just calling this angle theta max. So for maximum height also I call this theta max. So there is no universal convention. Okay, so we are just finding out the angle corresponding to maximum horizontal range, or let's name it theta r max. So theta for r max is, suppose, the angle, the initial angle for maximum horizontal range, maximum r. So in this equation now, we have r equals to u square sine 2 theta divided by g. So here also u square or u is a constant and g is also a constant, so only theta can change. So what is the maximum value of sine of theta or sine of any angle? It is 1. Okay. So for r max, sine of 2 theta should be equal to 1, and we are calling that angle theta r max. Okay, suffix is r max. So sine of 2 theta r max is equal to 1, and that means 2 times theta r max should be equal to what? Sine inverse of 1. Okay, the angle for which the sine becomes 1, and that is 90 degrees. All right, and therefore since 2 times theta r max is equal to what? 90 degrees. So theta or r max equals to 45 degrees. Okay, so if we project a projectile or if we throw anything in space at an angle of 45 degrees with respect to the horizontal direction, okay, with respect to the ground, then it will go to the maximum range. Okay, so it will cover the maximum distance along the ground. All right, so now next time if you are playing game of cricket, so you can use this relation. So you should throw a ball at an angle of 45 degrees so that it goes to maximum distance. Okay, so that means with minimum possible velocity, if you want to achieve the maximum distance, then the angle at which it should be thrown is 45 degrees. So what will be the value of r then? So we have r equals to u square sine of 2 theta divided by g, and when theta is equal to 45 degrees, r is r max. So sine of 2 theta is 1, so we get r max equals to u square divided by g. So the maximum value for the horizontal range is u square divided by g. Okay.